is last year's question 5. So that data from summer 2017. Have you done any exam questions with Philip? Yeah, in the lecture. No? Yeah. So you probably know that the exam has 8 questions. And each of them are 20 marks each. And you have to do question 1 and question 2, and then pick 3 out of the remaining 1. Okay, that's the system. Well, if you solve everything, then only the 5 best questions count. But well, you get these marks. Question 1, that's question 1 is simplex. It's the kind of shoemaker problem. So producing something. And we did an example of that question thing in the last week before Christmas. So if you go back there, a bit. Question 2 is some Phillips stuff, so usually some finance, I think. And then the remaining doesn't add up, does it? It's not 3 out of 5, it's 3 out of 6. So I said 3 of the 6 questions, and Philip sets 3 of the 6 questions, and I like to mix it up a little bit. So it's not like this question is only game theory, and that question is only linear programming, and that question is something else. But I usually like to put parts like this, A, B, so that you couldn't get away with only learning a little bit. Well, you still can get lots, so not make it too easy. So for example, this was last year. There's no guarantee that it's going to be the same or similar this year. But anyway, the part A is some kind of simplex method, and that's not what I want to look at now. But part B, worth 15 out of the 20 marks, is again similar to the assignment. So if you do the assignment, then you're quite ready to get this question right as well. So let's just quickly have a look at some of these answers. The first bit is, are there any dominated strategies in here? So can you quickly find any dominated strategies on these numbers? I'll try to. It's a red card. Red card. No, Catherine.
What?
For reading girl card. Have you found the dominated strategy yet? No, you're reading girl card. Okay, anybody? Yes?
B2.
B2 dominating what? Okay. Yeah, I think so. So B3 is dominated by B2, or you can say B2 dominates B3. That is probably right, because 4 is more than 3. Minus 1 is more than minus 2. Minus 1 is more than minus 3. And 2 is greater than 0. So it's what's called strong domination. So strongly means that they're all greater than. Weak means that some of them are equal rather than just greater than. Is there any other domination? Yes?
Is R1 weakly dominated by R4?
Is R1, right here, R1 weakly dominated by R4? I think it is. It's because 1 is greater than or equal to 1, so this one. 4 is greater than 2. 4 is 2. 3 is greater than 0. And 2 is greater than minus 2. Oh, it doesn't show. Okay. Can't fit everything in there. Any time? Oh, yeah. Okay, so that's correct. Now, Minimax. How does Minimax work? So one thing is you can, if you want, because R1 is dominated and B3 is dominated, you can just disregard and rest. But you can still also consider them if you want. Either way is correct. So what is the minimax analysis that we want to do here? We want to take the minimum of each row. Okay, so what's that? That's minus 0, minus 1. This one is minus 3 if you want. Minus 2. Do you agree? So this is min. And what's the max of each column? What are the maxima? 4. 4 in the like. Yeah.
3. 3. 2.
Yeah, that's great. So what's next?
Select the maximum.
Exactly. So the maximum is the largest one, so that's 0 here. And the minimum is the smallest one is the 2, so R4 and B1. So best strategies that are suggested by this Minimax are, again, B1, R4. Is that right? You keeping an eye on me? Question 3, does the game have a settle point? No, why not?
Because the two values, the maximum of the rows and the columns, are the same value.
Because the 0 is not 2. Yes, that's correct. So the maximum of the minima is not equal to the minimum of the maxima. No. Yeah, well, it isn't true. So what it means, or you could say as well, if you look at this point, so that's not an equilibrium. That's not an equilibrium because the blue player can improve by switching to B2, and also the red player in fact can improve by switching to R2. So it's not an equilibrium. An equilibrium that's coming from this min-max is called a saddle point. And you always get it from the min-max, and if that doesn't give you an equilibrium, or doesn't give you that's fine. Then there is no equilibrium of pure strategies. So you go on to the linear programming formulation, and so for part 4, so for part 4, you want the linear programming formulation for the blue player, it says. So, you have decision variables x1, x2, x4, and v. And these are the probabilities in mixed strategy. And this is the value. Okay. So I'm assuming everybody has been doing this for the assignment, so people kind of know how it goes. I've left out x3 because b3 is dominated, and so if you leave it there, which is also correct, then in the optimal solution you have to get 0 for that. But you don't have to put it in at all. And you get 3 constraints, R to the power 3, R4 for each of these strategies. R2 goes down like this, so you get 0 times x1 minus 1 times x2 plus 3 times x4 should be greater than or equal to b. In R3 you get 3x1 minus x2 is greater than or equal to b. And the last one is x1 plus 2x2 minus 2x4 is greater than or equal to b. The objective is to maximize the value. And of course you need x1 plus x2 plus x4. You want them, because they're probability distribution, you want them to sum to 1. And all of them should be negative. And I apologize for that in a minute of time, but this is just to prove that in 13 minutes that we spend doing this, we can get 15 marks. So it's not difficult. Any questions? All right then. After Easter, there's 1 week left. I will take the 2-hour block in the evening, and we'll do a couple more exam strategies, questions, something like that. As Philip is doing this 1 o'clock lecture. If I don't see you before the holiday, have a good Easter, and come back fresh and ready for the exam.